NASA picked where humans will land on the Moon in 2026. It's a crater rim in near total darkness, negative 400 degrees at the bottom. And if you fall in, there's no rescue. This isn't Apollo. This is something way more dangerous. December 2024. NASA revealed 13 candidate sites for Artemis 3, all clustered around the lunar South Pole. Not the flat, safe plains where Apollo landed, not the sunlit regions we've photographed for decades. Crater rims, ridge lines, permanently shadowed regions where sunlight hasn't touched ground in 2 billion years. The media celebrated. Scientists got nervous. Astronauts looked at the terrain and started updating their wills. Because this landing site changes everything. And it's not about making history, it's about water, survival, and beating China to the most valuable real estate in the solar system. Apollo landed near the equator. Flat lava plains, full sunlight. Neil Armstrong had miles of safe terrain. Artemis 3 gets a 100-meter landing zone on a slope in twilight. Why take that risk? Water ice, billions of tons, trapped in permanently shadowed craters, protected from the sun for eons. 2009. NASA's Lunar Reconnaissance Orbiter confirmed it. 2018. Direct detection of surface ice. 2023. Concentration maps showing exact deposit locations. This isn't trace amounts. This is mineable deposits. Industrial quantities. Split water into hydrogen and oxygen. You've got rocket fuel. You've got drinking water, breathable air, everything needed for a permanent base. Whoever controls this ice controls lunar exploration. And right now, it's a race between NASA and China. China's Chang'e 7 mission launches 2026. Same year as Artemis 3. Same target, South Pole ice. First one there establishes operational presence. Second one asks permission. 13 sites, 3 main regions. Shackleton Crater, the headliner. 4 kilometers wide, 2 kilometers deep. Rim gets 80% sunlight exposure during lunar summer. Bottom never sees sun, ever. Temperature gradient. Sunlit rim is 50 degrees Fahrenheit. Crater floor is negative 400. That's colder than Pluto. Landing target, the rim. Narrow ridge between sunlight and permanent darkness. Solar panels work. Equipment doesn't freeze. And the ice is 100 meters downslope. Connecting ridge, a mountain spine between multiple craters. Better solar exposure, access to several ice deposits. But landing area? Tiny. You're threading a needle onto a ridgeline in low gravity. Nobile region, collection of smaller craters near the pole. Most ice per square kilometer, but terrain is chaos. Crater on top of crater, boulders everywhere. Slopes up to 25 degrees. Each site mapped to 1-meter resolution. NASA knows every rock, but maps don't show you what it looks like when you're descending with the sun barely above the horizon, and every shadow looks like a cliff. Apollo astronauts landed in full daylight. They could see clearly, pick their spot, make adjustments. Artemis 3 lands in permanent twilight. Sun 5 to 10 degrees above horizon. Long shadows from every boulder. Depth perception destroyed. A rock the size of a car looks like a pebble until you're 10 meters away. The landing zone 100 meters wide, maybe 200 if you're lucky. Apollo 11 had kilometers. Armstrong spotted a boulder field, flew past it, found flat ground. Landed with 17 seconds of fuel. Artemis 3 doesn't have that option. The safe zones are pre-mapped. You land in that 100-meter circle or you abort. And here's the nightmare. The Starship HLS human landing system is 50 meters tall. You're landing a 15-story building on its tail, on a slope, in the dark, with zero margin for error. NASA's solution: autonomous landing, LiDAR terrain mapping, AI hazard detection, real-time surface analysis. The computer picks the exact spot, not the astronauts. If the AI can't find safe ground in the designated zone, mission abort. You traveled 240,000 miles and go home without landing. That's terrifying. But the alternative, manual landing in those conditions, is suicide. 7 days on the surface, 2 astronauts, 4 EVAs. Mission objectives: 1. Confirm ice deposits, not from orbit, actually drill, extract, measure concentration and purity. 2. Test processing. Can you melt it, purify it, turn it into fuel? Does the equipment work at negative 300 degrees? 3. Survive conditions worse than anywhere humans have worked. The ice isn't sitting on the surface, it's buried, mixed with lunar regolith, dust and rock, frozen solid into the ground. You're drilling permafrost, in vacuum, in darkness, with equipment that wants to freeze solid. Every drill bit NASA tests either freezes, breaks, or both. They're testing 20 different designs. None work perfectly yet. And if you extract ice, it sublimates instantly in sunlight, turns from solid to vapor, gone. The processing units need to work in shadowed areas, solar-powered from reflected sunlight off crater rims. Autonomous operation because astronauts can't babysit equipment in negative 300-degree darkness for hours. If this works, every future mission uses that ice. Mars missions launch from lunar orbit using lunar fuel. We never need to bring water from Earth again. If it fails, Artemis loses its justification. Congress asks why we're spending $93 billion to plant flags when Apollo did that 60 years ago. The entire future of space exploration depends on proving this ice is accessible and usable. While NASA announces, China executes. Chang'e 4, first far-side landing, 2019. Chang'e 5, sample return, 2020. Chang'e 6, far-side sample return, 2024. Chang'e 7, South Pole mission, 2026. Same year as Artemis 3. Same target region, same objective, water ice verification. But China isn't revealing landing sites. They're not debating for years. They're just going. Their timeline: Chang'e 7 in 2026, Chang'e 8 in 2028. Permanent research station by 2030. NASA's timeline: Artemis 3, maybe 2027, maybe later. Artemis 4 a year after that. Base discussions ongoing. The difference is funding structure. NASA needs congressional approval for every dollar. Every delay gets scrutinized. Every cost overrun gets headlines. China's space program reports to the State Council, budget approved, timeline set, delays classified, and international space law has a problem. It says resources can be extracted and used, but it doesn't specify exclusivity. If China establishes permanent operations first, they control the best sites. Not legally, practically. You want access to their ice deposits? You coordinate with Chinese mission control. Your launch windows depend on their schedule. Your landing sites avoid theirs. Second place means asking permission. That's unacceptable to NASA, but China's moving faster. Artemis 3 faces dangers Apollo never dealt with. Radiation, no atmosphere, No magnetic field. Cosmic rays constantly. Solar storms with no warning and no shelter except inside the lander. Temperature. Suit failure in shadowed areas means hypothermia in minutes. You're wearing a heating system that can't fail, ever. Terrain. Fall into a crater. You're sliding down slopes in 1/6 gravity with no way to stop. At the bottom, darkness, -400 degrees, and nobody's coming for you. Rescue, impossible. There's one lander. If it can't take off, both astronauts die. No backup, no rescue mission. You fix it, or you don't come home. And communication. The South Pole is at the edge of Earth visibility. Sometimes you have direct line of sight to Earth. Sometimes you don't. NASA's building a lunar satellite network, but it's not ready yet. During communication blackouts, you're on your own, making decisions with no input from mission control. Apollo had risks. Artemis 3 has exponentially more. But the difference is experience. Apollo was figuring it out for the first time. Artemis has 60 years of data, better technology, better suits, better everything, except the terrain. That's worse, much worse. The landing site isn't about flags and footprints. It's about infrastructure. NASA's picking the foundation for humanity's first permanent off-world settlement. The ice deposits that will fuel missions to Mars. The water that will sustain lunar colonies. And the clock is ticking. Artemis 3 launches 2026. Maybe 2027. China's Chang'e 7 launches 2026. Guaranteed. First one to successfully demonstrate ice extraction wins the moon. Second one explains why they're late. The site is revealed. The terrain is mapped. The technology is tested. Now it's just a matter of getting there. Landing, drilling, and not dying. Easy, right?